Back in 2017, a paper dropped with a really simple title, but an idea so powerful it would completely reinvent artificial intelligence. So in this explainer, we're going to break down what this new architecture, the transformer, is all about and why it literally changed the world of AI forever. To really get why this was such a big deal, we have to start with a basic question. How does a computer learn to do something like translate a sentence from English to German? It's a puzzle that scientists have been trying to solve for a very, very long time. For the longest time, the best AI models tried to do it just like we do, reading a sentence sequentially, one word at a time from start to finish. Seems logical, right? But it turns out this one word at a time method had some serious flaws that were really holding AI back. Okay, so let's dig into what this problem really was. Before 2017, if you were working with language AI, you were pretty much using one specific kind of model. These were called recurrent neural networks, or RNNs for short. And you can think of an RNN like a person trying to read a sentence through a tiny peephole. It sees the first word, thinks about it, and creates a little summary. Then it scoots the peephole to the next word and tries to combine that new word with its little summary of the last one. And it just keeps doing that over and over. This step-by-step process is, as the paper put it, inherently sequential. You literally can't process word number 5 until you've dealt with word number 4, and that creates a massive bottleneck. You can't just throw more computing power at it to speed things up because every single step depends entirely on the one that came right before it. So this really puts the two big problems side by side. RNNs weren't just slow, they were also really forgetful. If you had a long paragraph, the model might have completely forgotten the meaning of the first sentence by the time it got to the end. The new idea just flipped this whole thing on its head. What if instead of this slow, forgetful line, a model could just see the whole sentence at once, be super fast, and have a perfect memory of every single word? And that brings us to this incredible 2017 paper from Google. This wasn't just a small improvement, it was a complete break from the past. This quote, right from the abstract, is the heart of the entire revolution. They're basically saying, we're proposing something new called the transformer, and we're completely throwing out that old one-word-at-a-time process. Instead, it was all based on a concept called an attention mechanism. And this is it. This is the big idea in a nutshell. Instead of that narrow little peephole, the transformer model looks at the entire sentence all at the same time. It can weigh how important every single word is to every other word simultaneously. This lets it understand context and relationships between words, no matter how far apart they are in the sentence. So how does it actually do that? Well, the answer is a mechanism that's the real engine of the transformer. It's called self-attention. Okay, that's the technical definition, but what does it really mean? Well, imagine the sentence, "The cat sat on the mat." When the model is processing the word sat, self-attention is what helps it figure out that the cat is the one doing the sitting. It lets the model connect the dots between all the words to understand the grammar and the meaning. Now, the paper gets pretty technical here, but the core idea is brilliant. On the left is the basic engine. For every word, it basically sends out a question, a query, like, who is the main actor here? Other words present their key, saying, hey, I'm a noun. If the query and key are a good match, the model pays attention to that word's value, its meaning. But the real game changer was on the right, multi-head attention. It's just running that same process many times, all in parallel, so it can understand the sentence from lots of different angles at once. Multi-head attention is kind of like having a whole team of experts read the sentence together. One expert might be looking at the grammatical structure. Another one is focused on figuring out who did what to whom, and they're all doing it at the same time. This creates a much, much richer and more nuanced understanding of the text than just one peephole ever could. So now we have the main building block, this multi-head attention thing. So let's see how it all gets put together to create the full transformer model. And here it is, the now iconic architecture diagram. It might look a little complicated, but it's really just two main parts, an encoder on the left and a decoder on the right. And both of them are just stacks of those multi-head attention layers we were just talking about. The encoder's job is basically comprehension. It takes the sentence you give it, say in English, and it just chews on it, using all those attention layers to build a super detailed mathematical representation of what that sentence means. The decoder's job is generation. It takes that rich understanding from the encoder and it starts to write the output sentence, say in German. It actually generates the translation one word at a time. But here's the cool part. At every step, it's paying attention to the entire input sentence and all the words it's already written to make sure the translation is accurate and makes sense. So the theory is fantastic, but did it actually work? Well, the results they published in the paper weren't just good, they were absolutely groundbreaking. Take a look at this table. It compares the transformer against the best translation models of the day. Blue is just a score for how good the translation is. Higher is better. The best models were stuck around 26. The transformer didn't just beat them, it blew right past them. Now, a jump of over 2.0 BLU points might not sound like a lot, but trust me, in this field, that is a massive leap forward. This was a clear sign that a new king had arrived. It wasn't just a small step up, it was a whole new level. And here's the real kicker. It wasn't just more accurate. It was also way more efficient. Because the whole design could be parallelized, it could be trained so much faster and cheaper than the old models. We're talking better results in less time for less money. That's the combo that changes an entire industry. So really, the transformer model changed the whole game. It took machine learning for language from this slow single-file line to a big collaborative team meeting where everyone can see the whole picture at once and work together. And that leaves us with this final powerful thought. The authors of the paper suggested that maybe, just maybe, this attention idea could work for other things beyond a language. And wow, were they right. The transformer architecture is now the foundation of almost all modern AI, from ChatGPT to AI models that create images, music, and even video. The title "Attention is all you need" wasn't just a catchy phrase. It turned out to be more of a prophecy than anyone could have possibly imagined.